Matt here from ChemistryStudent.com. In this video, we're going to look at salt bridges. We're going to talk about what a salt bridge in an electrochemical cell is, how it works, and why it's important. Quick recap before we get cracking. A simple half cell is a metal in contact with an aqueous solution of its own ions. The metal is called an electrode, and the solution it's in, the electrolyte. Sometimes a half cell can contain different ions of the same element in the electrolyte, and the solid used for the electrode is a conductor with a low reactivity, like platinum or graphite. Within a half cell, there is an equilibrium established between ions in the electrolyte and atoms of the solid metal. As a result, the solid metal ends up with a surplus of electrons and a negative charge or potential, relative to the electrolyte, which has a surplus of positively charged ions and ends up with a positive charge or potential relative to the solid. Two half cells connected together makes an electrochemical cell. When two different half cells are connected together, electrons will move or flow from the electrode with the most negative potential, biggest surplus of electrons, to the electrode with the more positive potential, a smaller surplus of electrons. A bit like two containers of water connected by a hose. If one container has more water in than the other, then water will flow from the fullest container until the levels are the same. For electricity to flow and there to be an electrical current, however, we need the electrons to keep flowing, meaning we need the most negative electrode or half cell to keep undergoing oxidation. And to ensure the electrons don't start to build up on the electrode in the other half cell, ions in that electrode must keep being reduced to use up the incoming electrons. For this to happen, atoms in the negative electrode get oxidized and become positively charged ions that enter the electrolyte. The only problem is that as a result, the electrolyte starts to become more positively charged as the number of positively charged ions in it increases. This could then start to slow down or even stop the oxidation of more atoms in the electrode, as you can kind of think of it as them being repelled by the increase in overall positive charge of the electrolyte. It's like trying to force more positively charged ions into an already positively charged solution. The same thing is happening with the opposite charges in the other half cell, where reduction is taking place. Here, more positively charged ions are being reduced and turned into neutral atoms on the electrode. This effectively starts to make the electrolyte less positively charged and can start to affect how easily ions in the electrolyte get reduced. If oxidation and reduction starts to slow down or stop in each half cell, then no current can be maintained. To get around this, we need to be able to keep the charges of the electrolytes roughly constant, and this is what a salt bridge does. For every positively charged ion that leaves the electrolyte, a positively charged ion must enter, meaning the net charge doesn't change. And for every positively charged ion that enters the electrolyte, a negatively charged ion must also enter. A salt bridge is used that contains ions that can move freely between both half cells, but won't interfere with the oxidation and reduction occurring. Salts like potassium nitrate are often used as potassium, K+, and nitrate, NO3- ions, are really hard to oxidize and reduce, meaning they won't interfere with the reactions occurring. Salt bridges can get really technical and complicated inside cells with modern batteries. However, in a simple example, they can be made by soaking filter paper in a solution of the salt to be used, and each end of the soaked filter paper is placed into each half cell. The filter paper acts as a sponge and the ions can move across its surface, in and out of each half cell to keep the overall charges of each electrolyte largely constant. I hope you found this video useful. Please check out other relevant videos in the links given in the description below and visit ChemistryStudent.com for free notes and revision materials.